Hi, I want to talk to you about how to convert angles in radian measure to degree measure and how to convert from degree back to radian. If you don't know what a radian is, watch my video on what a radian is. I also have a video on the unit circle, and this unit circle has common angles marked out around it. Now, the purpose of converting between radian and degree is not to convert these common angles. You should know those once you start to really learn the unit circle. This is for the purpose of really figuring out 3 radians, how many degrees is that? Something that's not so common on the unit circle. But we will start off with our discussion on the unit circle. These angles are in standard position. Right here is 0 radians. And if we go all the way around the circle, we are at 360 degrees or 2 pi radians. If we go halfway around the circle, we are at pi radians, which is the same thing as 180 degrees. And that's what I'm going to use in this to help me convert from radians to degrees or degrees to radians. Let's look at that half circle here. And once again, this is at 0 radians or 0 degrees. And if we go halfway around the circle, we're at 180 degrees. That is the same thing as pi radians. And this is our key conversion here. If you can know that, you can easily set up ways to convert from one to the other. All right, so let's write that down. We've got pi radians is equal to 180 degrees. That means that if you think about it, 180 degrees divided by 180 degrees is what? That's equal to 1. And I'm going somewhere with this. Well, we can say that if pi radians equals 180 degrees, then we can substitute 180 degrees with pi radians in one of these two spots. So I could say pi radians over 180 degrees is also equal to 1, or 180 degrees over pi radians equals 1. Both of these fractions equal 1 because 180 over 180 equals 1, and pi radians equals 180 degrees. I'm going to write those two fractions on this card because we will refer to it a couple of times in this video. And so both these fractions equal 1, and that's what I'm going to use to convert from degrees to radians or radians to degrees. Let's take a look at an example. This first one says convert to radians. Notice this is not our typical angle that we have on a unit circle. It's not a common angle. So if you come across something like this that needs to be converted to radians, here's how we do it. We're going to say, okay, it's currently in degrees. Let's make it a fraction. If it's not already a fraction, make it a fraction. And I want to multiply it by the fraction here that will cancel out degrees. So degrees is in the numerator. To cancel out degrees, I need this fraction right here, the one with degrees in the denominator. So I'm going to say multiply it by pi radians over 180 degrees. And a few things are going to cancel here. The degrees will cancel. And before I actually multiply, I could knock out a few things. I noticed that 32 can be divided by 2. So that's the same thing as 16 when I divide it by 2. And 180 divided by 2 is 90. Now, I also noticed, and maybe you saw in the get-go, that this was divisible by 4. I notice I can divide this by 2 as well here, and that divided by 2. So let's go ahead and do that to make multiplication easier. So I get 45. When I divide that by 2, I get 8 right there. And I don't see anything in common between 8 and 45. So as I multiply straight across, I get 8 times pi radians. That gives me 8 pi over 45 here, because 1 times 45 is 45. And this is in radians. So that's the equivalent of 32 degrees in radians. Now, likewise, we can go from radians to degrees. So this is just 1 radian. So if you watch that video on when I asked you what is a radian and we talked about marking out those paths around the circle, we got the idea of what 1 radian is, but it's not a common angle on the unit circle. Well, let's see what that actual angle is in degrees. So I'm going to go back and say, let's make it a fraction since it's not already. I get 1 radian over 1, and I want to cancel out that radian. Now, they're abbreviated here as rad, because that's what they are. They're rad, right? But radians in the numerator here, I want to cancel it out, so I need to multiply it by the 1 with radian in the denominator. So I'm going to say multiplied by 180 degrees divided by pi radians. And I'm going to multiply from here. Well, the radians will cancel out, and I'm left with 180 degrees over pi. Now, that's not a radian there because the radians canceled, so it's just 180 divided by 3.14, and so forth with pi there. So if you actually want to get a number, so you can get an idea of what it is, you can say 180 degrees divided by pi, and you get 57.29 approximately. 57.29 degrees. And with me, I'll tell you what I want that rounded to. So make sure you put the degrees there with it. So that's converting from radians to degrees. Now, I do want to take you through about 8 more examples here, 4 of each, so that way you feel a little bit comfortable with actually going through a bunch of these and seeing some with actual radians with pi's in them and all that sort of thing. So let's take a look at that. We're going to start with converting to radians, and then we will switch to converting to degrees. First one here is 18 degrees. Give the video a pause and try that out. All right, I take it that you've given that a try. Let's see if you got it right. So I've got 18 degrees. Make it a fraction. So if I put it over 1, all right, I'm going to multiply it by the fraction that's going to have degrees in the bottom, which is pi radians over 180 degrees. So pi radians divided by 180 degrees. I notice that, hey, 18 will go into both of these. So 18 goes into this, and I get 1. 18 goes into this, 10 times? I get 10. And so this leaves me with pi radians over 10. Or you can say pi over 10 radians. You don't have to put the radians in the numerator. You can put it off to the side if you want to. It's just a unit of measure. So pi radians over 10 is my answer there. Next one, 720 degrees. Once again, make it a fraction. And notice when we multiply, we're going to multiply it by the 1 with degrees in the bottom. That's the first fraction here. So I multiply it by pi radians over 180 degrees. I notice right off the bat, they're both divisible by 10, and the degrees will cancel. And then 72, you can divide that by 9. 72 goes into 9 8 times. Or 9 goes into 72 8 times, right? And then 9 goes into 18 twice. And then looking at that, I can also see that both 8 and 2 are divisible by 2. So I get 4 there and a 1 there. And this leaves me with 4 pi radians. 4 times pi times the radian, and then 1 over 1 there. Or 1 times 1, I mean. So 4 pi radians is my answer. Next one, remember we can also have negative angles when we're talking about the standard position of an angle. Those go clockwise around, don't they? So I've got negative 400 degrees, and I want to convert that to radians. Looking at this, I'm going to make this a fraction, put it over 1. And I want the 1 with degrees in the bottom. That's going to cancel out that degree up top. So multiplying it by pi radians over 180 degrees, and the degrees will cancel. I notice they're both divisible by 10. That cancels out. And then let's see. I know that 18 is divisible by 2, so that gives me a 9. 40 gives me a negative 20. And that's as far as I can take that one, canceling out before I multiply. So I get negative 20 times pi gives me negative 20 pi radians. 1 times 9 gives me 9. And so you get negative 20 pi over 9. That is your angle in radian measure. One more here at the degrees. Let's put this over 1 first. And if you haven't caught on yet, notice whenever I'm converting to radians, I'm multiplying by pi over 180. Pi radians over 180. Pi radians over 180. I don't expect you to memorize that. In fact, I prefer you not. I prefer you to make both those fractions. They're pretty easy to make. And then think about it. Because then I'd rather you understand what's going on than just memorize pi over 180 when I'm converting to radians. So write these two out and then figure out which one you got there. It's pretty simple once you do it a couple of times. So multiply by pi radians over 180 degrees. The degrees here will cancel, and they are both divisible by 10, so I can knock that out. And this gives me 7 pi over 18 radians. And there's my answer there. All right, so that takes us through converting to radians. Now we're going to take a look and convert things to degrees. So I'm going to switch out my papers here. And we got 4 problems here to go through that we convert from radians to degrees. Now, a lot of times when we're looking at these, we don't actually write down radians. If it's the context is talking about an angle, we know we're talking about radians here. So if you don't see that written down, just write radians in the numerator. That's where it should go. Because if I multiply 5 pi over 4 by radians, if we treat it like a number, it's like we're putting radian over 1. And so you get 5 pi radians over 4. And so I want to convert this to degrees. You can go ahead and pause the video, give that a try. All right, I take it that you gave that a shot. Let's see how you did there. So I'm going to multiply it by the fraction that will cancel out radians here. So notice that radians is in the denominator here and in the numerator right there. So I'm going to pick that one on the right. 180 degrees over pi radians. And the cool thing about this is a lot of times we get these pi's that cancel out and the radians cancel out. And now I'm just dealing with numbers again. So I know that 4 will go into 180 degrees 45 times. So this becomes a 45. 4 goes into 4 once. And so 5 times 45 is what I'm going to get there, which is, let's see here, 225. And this is in degrees. And there's our answer. Do mark that there is a degree there. Even if it's in context, we want to make sure that we being obvious that it is degrees. Next, I got 11 pi over 9. Once again, I'm going to pick the fraction that will cancel out the radians. If you don't have the radians there and that kind of bothers you, just pick the one that's going to cancel out pi. You know, sometimes we have, most of the time with radians we have a pi. Sometimes we don't, though. So I want to multiply it by 180 degrees over pi radians. And so the pi's are going to cancel out here. I know that 9 goes into itself once. 9 goes into 180 20 times. And so 20 times 11 is 220. And 1 times 1 gives me 1. So this is going to be 220 degrees. Not too far off from our last one that we just did. All right, next one. Once again, I'm going to be multiplying by 180 degrees over pi. The pi's will cancel out. 30 goes into itself once. It goes into 180 60 times. So I end up with 60 times 37. And I'm going to punch that one in on my calculator. I get 2,220 degrees. And that's my answer for that one. One more here. Once again, we can have negative angles, so it's not a bad idea to go ahead and practice one of those. So I've got negative 5 pi over 3. I want to multiply it by the fraction. It's going to cancel out those pi radians. And so I'm going to pick the one on the right again. And just like the last 4 problems we did, we notice there's a pattern here. This time it's the other fraction that we use each time to cancel out pi and the radians. So these two right here cancel. 3 goes into itself once. It goes into 180 60 times. So I end up with 60 times negative 5, which is negative 300 degrees. And that's my answer right there. Okay? Hopefully that cleared up some things for you, so that way you could convert from radians to degrees or degrees to radians. Go ahead and try out the practice problems I have for you. If you have any questions, let me know. I hope this helped you, and thank you for watching. Have a great day.